you go. Here we go. Homework. Let's check your answers. 1 through 6, folks. Number 1, you should have had cosine t. Number 2, you should have had tangent t. Number 3, you should have secant x. Number 4, sine x. Number 5. What's answer number 5? -1. I'm going to show you a very, very easy way, I know, to solve that problem. You're going to, seriously, y'all better get ready because you're going to want to smack somebody near you. I'm just saying. You better pick out the right person. Number 6, tangent x. Is this not the easiest stuff ever? It is so easy. Now, do you want to see number 5? Y'all better get ready. You better get ready. Number 5, here we go. Tangent x, tangent squared x. Put that class ring mess up. Look at it later. Minus secant squared x. Okay, folks, how many of you did this? Sine over cosine times sine over cosine minus 1 over cosine times 1 over cosine. Hands up. Claim it. High five in the air. Did you get -1? Okay, some of you did. That a girl. Some of you didn't. That's okay. Get your card. Just get your card out. Just for a second. Get your card. Okay? I want you to look on your card. Y'all better get ready. You better brace yourselves because somebody's going to get smacked. Look at your card and then tell me what tangent squared is equal to. Minus what was already there. Stupid card. Now, what are your like terms? Stupid secant squared x. Minus secant squared x is what? For real. Here we go. Let me explain it again. All right. The part that I underlined in blue, tangent squared, under the trig identities. You wrote it yesterday. Put that at my desk, please. Did you not write it down? You got it there, right? Okay, tangent squared. What is tangent squared equal to?
Oh, secant squared. Yeah, I got that. But I'll get what you got. I got it now.
Shut up.
Yeah,
don't hit anybody. Doesn't that make you mad? Because y'all, how many of you, I did this problem using difference of squares. Now, where would I have gotten difference of squares from? It's a squared term minus a squared term. It took me seven steps to get -1. Some of you did this, and this is the part I told you, that some of this stuff's going to make y'all cry. That's the way my brain feels sometimes. This. Some of you did it this way, and it was totally fine. You could have done it this way. Sine squared x over cosine squared x. This is the part that's going to make some of y'all absolutely bonkers. Did anybody go this way? All right, did you get the final answer? Or you got close? Okay. What are you saying? I don't have to. I can. That's another way to solve it, but I don't have to. All right, but do you see what you have to do? I'm telling you, the first thing you need to do is you need to look at that card and see, is there a way that I can eliminate one piece of this or the other? And I said it yesterday in this class, and I think I said it yesterday in this class. This is about thinking ahead. This is like, how many of you guys have played? Everybody's played checkers, right? Has everybody played checkers? I'm not very good at it, but I am decent at rook. And in Rook, you always have to think ahead. What? If I throw a 1, because we don't play with the Rook high. We play with the Rook between the 10 and 11. Not that anybody cares or knows what I'm talking about. But, does anybody in here play Rook? Okay. Do you play Rook high? Or do you play in between 10 and 11? High? Okay. For me, see, we play with the Rook between the 10 and 11. You guys will totally get this. Meaning, my 1 has all the power. I want to have in my hand the 1, the 14, 13, the 12, 11. Boom, then the Rook. Okay? So in Rook or spades or whatever you play, I'm thinking ahead. All right, if I throw this 12, I'm hoping somebody's going to throw the 14, so the next go round, I can throw the 11 and catch the bird. You understand what I'm saying? It's thinking ahead. Just like in checkers. If I move here, then he might move here and double jump me, right? That's what we're doing with this right here. You got to always think ahead. What can I change in my expression that can cancel something out? Or can I smush something together? Okay? If I would have gone about this problem this way, then I would have rewritten one numerator over one denominator. And again, I'm going to look immediately to my card. Do I have anything that resembles sine squared x minus 1? I got a 1 minus sine squared x, don't I? So in my head, I think, okay, if I factor out a -1, then watch what I can do. I can change the way this thing is written, and I can make it suit my own purposes. Now I'm going to rewrite this. One minus sine squared x. And folks, on your card, what's 1 minus sine squared x? Cosine squared. So watch what I'm doing. What am I setting up? So I can take out my cosines and it still leaves me with -1. There is definitely more than one way to skin this cat. Okay? So many, and this is what some people are like, oh, just show me one way. Just show me one way to do the problem. I don't care about 14 different ways. And I get that. But this is the part that I think is so cool about this. Because Kayla can do it one way, Ebony can do it one way, Cindy can do it one way, I can do it a totally different way, and we can all get to the same answer in the end. I think that's kind of groovy. I think it's kind of really, really groovy. It is groovy. Bring that word back, y'all. Groovy. What do you think? Questions? How about the rest of the problems? Were they okay? Going to kind of think old school, because you know I like old school. Cosecant x divided by cotangent x. And you guys can go on and do your bracket thing. I'm not going to do a bracket nothing. I'm going to go old school on this. Okay? Cosecant x divided by cotangent x. Always thinking ahead. How can I rewrite? Sometimes you just have to do these problems over and over again. What would you do to cosecant x? How can I rewrite that? 1 over sine x. Okay? Divided by. How can I rewrite cotangent? I could write 1 over tangent, but... Say it again. I just didn't hear what you said. Fix it, cosine over sine. There we go. Now, why would I choose to write cosine over sine versus 1 over tangent? Because this is the play that in my head I'm thinking, okay, if I play the 11 now, then I can wait and I can catch. I'm thinking ahead, all right? Thinking ahead. What am I going to do with this? This thing divided by cosine over sine, what am I going to do? When I flop it, when I copy change, flip. We ain't flopping nothing. Then what's going to happen? Then my signs cancel out. And see how I set it up? I set this in motion so that I could do this. Now what am I left with? 1 over cosine, and then I can write that in a better way. How can I rewrite that? Secant x. And it's not just secant, it's secant x. Okay? What do you think about that? Facile? Cosine squared times tangent squared x plus 1. Now, if I have a binomial, where do I want to look immediately? Look at your card. Look at your card. If you got that binomial, you need to look at the card. Is there anything on the card that looks like tangent squared x plus 1? Secant squared. All right, so look. So now I'm going to rewrite cosine squared x times secant squared x, right? Hey, finish that out. You know what to do with that. Go ahead. Thinking ahead. What can I do with cosine squared? Anything? Do I need to do anything with it right now? Just put it over 1. Let's see how this is going to play out. Because if I put it over 1, then what's going to happen? Button when I walk back over here. So, how are we going to complete this problem? Because there are never distractions. And we're just thinking about this and pondering and thinking our thoughts and and how are we going to how we are going to rewrite secant squared x as a reciprocal. And then what? Don't look at them. Don't look out the window. Don't look. And then what? Cross them out. Cross them out. What am I left with? 1. How many of you had 1? Again, that is just a cruel mathematical joke. How do you start with that up there and you end with 1 or 0? Because it's going to happen. Or -1 and you're going to work. I mean, you're going to work so long on these problems and then you're going to get to 1. And you're going to think, that's just wrong. And it is kind of wrong and kind of evil in a funny kind of way. Yes? Why do I what? Flip it here? From here to here because this is the reciprocal. Secant is 1 over cosine. Absolutely. Yes. All righty. Here's another one. Here's another one. Check this out. Secant x cosine x minus cosine squared x. Now you just know already that you can't get by with skipping steps on this. I'm not going to let you. And I don't care if you get the right answer. If you don't show me how you get to the correct answer, I'm not giving you full credit. That's being a fart face. I don't really care. Okay? What are you thinking? What do you need to do with this? Okay, fair enough. Let's do that. Now what? Cross cancel cosines, right? Everybody with me? That leaves me with 1 minus cosine squared x. Now, to me, this is like those signs in Vegas. Bright lights. Blasting at you. Ah, why? It looks like we need to look at the card. See how bright and shiny that is? Beautiful. Look at your card. If you end up with a binomial, you need to go straight to your card. Do we have anything that is 1 minus? Just shut up, Miss Perry, and write sine squared x. I hear y'all. That's what I'm hearing. Sine x squared. That's what y'all are saying to me. Shut up. I'm recording it. Kaylee's like, I know. I hear you loud and clear. Fart faces. Get those glasses off. Questions on this? Is this facile or difficile? Facile. Ooh, here's another one. Smarty McFarties. What now? Children, I do love y'all. I really do. But I so hear what you're saying without saying. If you could only hear what I'm thinking without saying. Just think about it. What about this one? Ooh. Ooh. Because it's already in fraction form. It does look nasty, but here's the thing. I know that there is an easier way to approach this problem than the way I approach it. But I know, honest to goodness, if I tried to flip things the way they are right now, I would make a careless mistake, and y'all know how I am about careless mistakes. I don't want to do that. So when I look at this, I go, okay, I'm going to deal with this. I'm going to deal with it. 1 over. How can I rewrite cosecant squared x as a reciprocal? What? That's what I want to go with. Okay, look. 1 over sine squared. What is cosecant squared? Just hold on, look. Hold that thought. Getting ready to go there. I've got to write it here first, and then I'm going there. Okay? Because I need to see this as a fraction plus a fraction. I'm going there, Morgan. Okay? If I go 1 divided by that fraction, then this is going to be 1 divided by what? 1 over cosine squared. Bless you. Okay. Now Morgan's like, wait a minute. We got to fix that. And I agree, because that makes me crazy. This is like complex fractions, and y'all know there ain't nothing wrong with old school, so we're going old school. Get ready. 1 divided by 1 over sine squared. Okay? Plus the quantity 1 divided by 1 over cosine squared. Now, at this point, what am I going to do? I'm going to copy, change, flip. I'm going to multiply by the reciprocal. And now is when it's going to look, I mean, like I'm totally fine with it like this. But I'm going to have copy, change. Anytime I divide fractions, I always can multiply by the reciprocal, copy, change, flip. Okay? So I'm going to flip over 1 minus sine squared, and it's going to give me sine squared over 1, right? Plus 1 times, excuse me? And then, what am I going to do? What is 1 times anything? That thing. So 1 times sine squared is sine squared x, right? What's 1 times cosine squared? Cosine squared. Vegas lights right now. Boom. Boom. Where do you need to look? Card. What is it? 1. Again, with the stinking 1. For real? Now, what is the probability? You cannot always just answer 1 and think that the probability is high that you're going to get the answer correct. Look at your card. Pythagorean identity. Sine squared plus cosine squared is equal to 1. Okay? These are the questions you need to be asking. Anytime I see a binomial, I'm immediately like, oh, I like this right here. Okay, do I have anything that matches? Do I have anything that matches? Because, folks, here's the thing. We're going to add in the next 2 weeks 6, 7, 8, 9, 10, 11, 12, 13. 13 more formulas. 13 more identities that we will have at our disposal to use. So, get comfortable referring to your card all the time. Leslie.
How do you know whenever to use a reciprocal identity?
Not tomorrow. Tomorrow's quest is on the law of sines, law of cosines, and Heron's formula. Okay? Your quiz test, I haven't decided what it is, so we'll just call it a quest. It is card friendly, yes. It is friendly to all cards. Yes. Here we go. It is a very friendly quest. It is also very friendly with word problems. Ha ha ha. Simplify. Go. What is 1 over cosine squared? Secant squared. I got a binomial. Where do I need to look? Card. What is secant squared x minus 1? Tangent squared x. Did you have secant squared x? Cosine squared x. All right, let's go that way. So you did this. Because what is 1 over cosine? Secant. So if it's 1 over cosine squared, it's just secant squared. Okay? That's all. Isn't that cool? Don't you love to figure that out after you've worked the problem the long way? What is this? Hey, what am I going to do now to this? I'm subtracting. What does Easter do? Smush it together. Watch. Go to your card. 1 minus cosine squared. Oh, look. That's straight on my card. Sine squared x. What's sine squared over cosine squared? Shamalama ding dong. Tangent squared. 2 different ways to solve the same problem. I think that's cool. I think that's very cool. It is a mystery. Ooh. Stop it with that stupid movie. All right. That sounds like something that will come out of that movie we talked about yesterday. Magical Land. Why? Thank you. The magical. Ooh, it's a mystery. How many of you had tangent x squared? Tangent squared x. Very good. High five, y'all. Okay. It is a mystery. Yeah. I watched it when I wasn't such a kid. I love cartoons. The old ones. The new ones are stupid. The new Scooby-Doos suck. The old ones, when they went into scary houses and things. SpongeBob's all right. He's all right. Oh. Thanks, Jansen. All right, look at this one. Coolness right here. Ooh, got a whole bunch of stuff going on here. Sine over tangent. Plus 1 over secant. Here's what I would suggest. I would suggest going old school on this first piece. Sine x over 1 divided by tangent x over 1 plus this 1 over secant thing. Just bear with me a second, okay? What am I going to do? What am I going to do? What can I do to tangent? Sine over cosine. All right, here we go. Sine x over 1 divided by sine over cosine. That 1 over secant. This is what Luke was talking about earlier. It's just right, Luke? This is at the point that you're going, I can't do it. He just looks at it and goes, it's cosine, right? Okay, I can't do that. I'm going to do it my way. I will get there eventually. Bless you. Here we go. Copy, change, flip. Y'all with me so far? You see what I'm doing, yes or no? Okay. Can't cancel out anything because not yet. Not yet. Hold on. Secant is really 1 over cosine, right? And this is what Luke was talking about. Just flip it. I cannot do it. I can't do it. You cannot make me do it. I'm not going to do it. Cindy, what do you want to do over here on the left? Cancel out the signs. I agree with you. Okay? That gives me cosine x. Okay. That one's whittled down. Yay. Now, plus. Go ahead.
Okay, how did you do this? I didn't think it was the 1 over cosine, but whenever you divide it, do it.
I'm getting ready to flip it.
Okay.
I had to change secant into 1 over cosine. And now I'm going to copy, change, flip. Okay? So I've got 1 times cosine x. And dang it, Luke's right again. What's 1 times cosine? Can we do this? Can I do this? More importantly, can I just do this from now on? I will try. What we get? Cosine x plus 1 times cosine x. What is it? Cosine x. What is cosine plus cosine? 2 cosine x. Very good. Seriously? I can have a 2 in front. Yeah, it's just a coefficient. Right? What do you think about that? Because what is 1 alligator plus another alligator? Dose alligators, not alligator squared. That's why. That's why. Right? I need a bubble around me. So I can just bounce off things. What do you think? And I won't hurt anyone or myself. More importantly, myself. Or India. Poor India. What do you think? India's always the one that's getting hurt up here because I accidentally throw a rock at her or stuff. You know, not really. No, that's a lie. I haven't really thrown a rock at her. Nor has anyone else thrown a rock at her, I don't think. Have we? It's all being recorded right now, India. But I might be calling you Cyndia. That's really who I'm talking about, my student name, Cindy. I don't know who India is because this is going to be on YouTube with my 1 million views, y'all. They don't need to know who my students are like Cyndia and Kelly and Elizabeth. Who is that? Or, yeah, here we go. Do you have questions on this? Stop distracting me. Do you have questions at all? Okay, good. Here we go. Here's another one. Here's another one. Oh, 30 minutes of Kelly and Cyndia and Rochelle and Elizabeth. Here we go. I don't know. It's our student. And Taylor back there. And Taylor back there. Really?
All names.
No, because you're trying to distract me from doing my work. Trying to think of you a name right now, but I can't. And I'm not going to call you by your real name, which is Sue. Your name. Boy named Sue. Who sang that song? There we go. See, now you have to watch the video to figure it out. No, I don't really care that much. All right. All right, y'all. Oh, my goodness gracious. This problem. Okay, I'm going to just put this problem out there, okay? And I'm going to put a star by it. And I want you to think about this, okay? You are going to have through Easter break to come up with the answer to this problem. Now, I'm going to just show you, because we're not going to study on this tomorrow. We have our quest tomorrow, right? Law of sines, law of cosines, and Heron's formula, which has nothing to do with trig identities. So here's what you're going to do. You are going to, because of this problem for me, 1, 2, 3, 4, 5, 11 steps. 11 steps for me. Now, if you can prove it, simplify it in fewer steps and show every step along the way, that's cool. I want you to do this on your own. Okay, so leave you some space. I'm going to move on to this because I want you to see it. What happens when all we've dealt with so far has been squared trig functions. And now we got these cubed. Okay? What do you think? What can we do with this? Let's see wheels turning. What can I do with that? Say it again. Just do it. Do what? I could add the 3's if they were the same trig function. What? Yep. Because if sine cubed x over cosine cubed x, if I can write that, then that is equivalent to tangent cubed x, right? You writing this down? Okay. Times, there we go, 1 over sine cubed x. And now what? Cross cancel sine cubed x. And 1 over cosine cubed x is actually just what? Secant cubed x. Take a look at it. All right, see what you can do with that. Thoughts? Quit whining. Come on now. It's not attractive. Whining is never attractive. Oh, really? For real? Change it around and let's think about it this way. What if I wrote it this way? C cubed plus S squared C. What if I wrote it that way and I said to simplify that? You still don't know what you would do? Oh, you're very warm. Woo! What are you doing though? By taking out a C, what are we actually doing? Factoring out the what? Yes, factor out the GCF. There we go. If you factor out the GCF. If we were to take out a GCF here, we would have C times the quantity, C squared plus S squared, wouldn't we? All right, so let's apply that. All that is algebra, folks. Let's apply that algebra skill to this problem. What is my GCF? Cosine x. All right, watch. Cosine x times what gives you cosine cubed x? Cosine squared x plus what? Sine squared x, right? Now, blaring at you. Boom. Boom. Those Vegas lights. What do you need to look at? Look at your card right here. What is cosine squared plus sine squared? 1. Holy moly, what's cosine times 1? Are you kidding me? Yes, sir. No, I have to factor out the GCF first so that I can get cosine squared plus sine squared, so that I can make that factor 1. Okay? No. It has to be cosine squared plus sine squared, or sine squared plus cosine squared. Okay? That's a good question. Very good question. No, no, it would not be equal to 1, because the identity says cosine squared plus sine squared is equal to 1. And why? What's that based upon? The unit circle. That is the equation for the unit circle. So it has to be squared squared. Okay, that's a very good question. All right, so what are we going to do? Any questions at all? Here's what we're going to do. We got a little work to take care of. All right, so you're going to go back and you're going to think on example 7. And I better put attempt. Oh, some of you better do more than thinking about it, because you're being a smart hiney. You've met your match with that. And you know that. The second thing you need to do, and this is going to be due after Easter. Okay? You don't even have to do this tonight, because I want you studying law of sines, law of cosines, and Heron's formula tonight. But this is what you're going to do for me. Page 242, 9, 13, 14, 16 through 18, and 22. And don't you dare come in here next Wednesday and say, I forgot. Because I'm going to go, oh, it's a 0. And won't even care. It ain't hurting me. You're hurting yourself by not doing your work. Next thing, for tonight. Study. Law of sines. Law of cosines. Heron's formula. For your test, quiz, test, quest. Okay? That's what you need to do. You need to use the time right now to do something other than talk. Okay?